So far, we got to know that when electric current flows through the circuit, when the circuit is complete, then an electric current can flow through the circuit, and at that time, the bulb will glow. Now, what exactly happens that makes the bulb glow? Why is it that that current flow makes the bulb glow? So the bulb glows because the current is allowed to flow through the wires of the circuit. Now let's try to understand this with the help of a same example of a bridge. So you have the same bridge connecting two towns, town A and town B, and suppose someone is trying to reach to town B from town A. And suppose the bridge is not broken. Say somebody has spilled something on the bridge, maybe someone has spilled oil on the bridge, some mud or sand on the bridge, because of which the person or the cyclist is not able to travel. So even though the path is there, bridge is there, but the bridge doesn't allow the cyclist to move forward. So path is present, but the path is not allowing the person to move on it. So in that case, do you think that the cyclist or the person will be able to reach to town B? No, right? Because even though the path is there, he is not able to move. So, in a very similar way, in case of a circuit, let's suppose that the circuit is complete, path is complete, but these wires, they do not allow current to flow through them. So, see, the wires do not allow the current to flow through them, even though the circuit is complete. So, current will not flow, right? Are you getting my point? So there are two things. One is the circuit should be complete, that is, the path should be complete. That is one requirement for current to flow. The second requirement is that the wires or the material of which the path is made up of, that material should allow current to flow through it. So now you might ask, what does that mean that some material might allow current to flow through them and some other materials might not allow current to flow through them? Yes, so based on whether a material allows current to flow through it and a material doesn't allow current to flow through it, we have classified materials into three different types. See, some materials are good conductors of electricity, some materials are poor conductors of electricity. So, depending upon whether the wires of which the circuit is made up of, they allow current to pass through it or not. The result depends whether the bulb will glow or not. So, it's also important the wires, the conductivity of these wires or the material, that is important. Conductivity of the material is important. So in this, the material is nothing but here the wires. So these wires also need to be good conductors of electricity so that the bulb can glow when the circuit is complete. So based on this, let's try to look at the different types of materials which have been classified based on their electrical conductivity. Now there are three types of materials. First is the conductor, second is semiconductor, and the last one is insulators. So conductors have high conductivity. What is the meaning of conduction? Conduction means the material allows electric current to pass through them. So they conduct electric current. That is why they are called conductors. In fact, they are also known as good conductors because they are quite good at conducting electricity. So they allow good amount of electric current to pass through them. And the example of conductors are metals, water. These are the examples of good conductors of electricity. The extreme other end of conductors are the insulators, which have very low conductivity. In fact, in many of the cases, they do not allow electricity at all to pass through them. So that is why they are also known as poor conductors. So some of the examples of poor conductors are plastic, wood, glass. So they are all poor conductors of electricity. They do not allow electric current to pass through them. In between of conductors and insulators are the semiconductors. Semiconductors, semi means half. So they conduct, but they do not conduct as good as the good conductors. But they are not as bad as the insulators. So basically, they are having intermediate conductivity. So some of the examples of semiconductors are silicon, germanium, gallium arsenide, polyaniline. These are all examples of semiconductors. Now, the functioning and working of semiconductors are little complex, so you will learn it in your higher classes. So right now we are going to focus mostly on the conductors and insulators because, here mostly in this chapter we are going to focus on conductors because we want to see how electric current produces chemical change in a solution through which it passes. So when we say that current passes through a solution, that means the solution has to be good conductor. So in this lesson, we will focus mostly on conductors. So I hope you understand it. You understood it now that some materials would be conductors, some materials can be insulators, some materials can be semiconductors. Now we prefer to use the term good conductors and poor conductors rather than conductors and insulators. Because when we say insulators, insulator term means something which doesn't allow current at all to pass through them. But basically, most of these materials, which we call as insulators, they also allow some amount of electric current to pass through them under certain situations. So that is why it's preferable to use the term poor conductors rather than insulators. Poor conductors means they also conduct electricity but very poorly. So they have very low conductivity. Thank you.